Our next speaker is Ben Salama, the Global Connected Operations Lead for Accenture Mobility, talking about the Internet of Things, the fourth industrial revolution. Just to note, this is M2M World Congress. We seem to be talking a lot about IoT up until now. Presumably that will continue now. I'm threatening, if nobody does it beforehand, that during my presentation this afternoon, I'll explain what I think the difference is. So if anybody's wondering, I'll talk you through that this afternoon. But Ben, over to you.
Good. Thanks very much. Yeah, actually, it's one of the things I'm interested in hearing. Good morning, everybody. My name is Ben Salama. I work for Accenture Digital. I lead our industrial Internet of Things practice on a global basis. It's one of we call that connected operations. It's one of our four key towers around the Internet of Things, the others being our connected transport practice, our connected spaces, which is smart cities, smart buildings and home, and our connected health. So I'm going to be talking about really what we're seeing in terms of the industrial Internet of Things, what our clients are asking for, and I'm going to close with actually a specific case study of a project that I think is actually quite a good example of the sort of case studies and stories that we're going to be seeing going forward in the IIoT. So Gartner identified IoT as the most hyped technology in 2014. I think in a large part that's probably to do with the impact of wearables and IoT in the consumer space. So obviously the launch of Apple Watch, of other wearable devices, the inclusion of technologies such as NFC, beacon technology and so forth in retail, and the new interest, I think, or the renewed interest that we've seen in the connected home as smart meters start to roll out in a much more pervasive way across the world, and utilities and telcos sort of picking up, and white goods manufacturers picking up on the opportunity there. So clearly a very strong buzz and a very strong hype around the Internet of Things from a consumer perspective. But I think where we believe some of the biggest impacts on society and indeed across our economies are going to take place is really in the industrial space and in a commercial space. So really the sort of top half of this picture, and that's what I'd like to sort of focus on during the next 10 minutes or so. This is being called by many Industry 4.0, so a reflection really of this being a new technology wave that is instrumenting for us the next industrial revolution, sort of building on the technology waves we've seen around steam, around electricity and automation for the first three. And if we look at sort of what are the key drivers that are creating this environment and this ecosystem and putting in place these things, I think there are things that probably most people in this room are very familiar with. So it's all to do with very, very dramatically changing price of chips, of the reduced price of creating sensors, and the ability to connect those in a ubiquitous way across into devices and into assets. The real growth of wide range and opportunity across connectivity, so whether that's, of course, 3G or 4G, but whether it's mesh networks, Bluetooth, NFC, and so forth. The pervasiveness of our internet backbone, the low cost and the increasingly low cost of large-scale data centers that are supporting cloud deployments, and of course, driving all of this software, and probably most important of all, the analytics and the analytical algorithms that are driving the value and pulling out the value out of the data that is being created. So if you take those, combine that with the ability to connect large number of devices, all of a sudden we're looking at an environment where our industrial world is being radically transformed, and really we're starting to be able to bring together for the first time OT technology and IT technology in an industrial environment. Sorry. So I won't dwell on this too much. Both of my previous two speakers here have spoken about the opportunity that the industrial Internet of Things and Industry 4.0 represents. I would say that one of the best studies I've seen here is actually a piece of work that was commissioned by the World Economic Forum last year. So their IT group formed an industrial internet working party and commissioned a set of research over the last 9 months, taking a look and sort of speaking to opinion makers, to technology adopters in this space, and coming up with really a picture as to the opportunity that was being created by the industrial internet. What they identified was that there were some key industries that were going to benefit the most from the industrial internet. Those, as you might imagine, were sort of manufacturing, healthcare, agriculture, oil and gas, mining. Together, they represent something like 2/3 of the world's entire GDP. And the estimates were that over the next 15 years, there could be an increase of excess of $10 billion in GDP, $10 trillion, should I say, in terms of GDP uplift as a result of the industrial internet. In the UK alone, that represents close to a 2% uplift in GDP. So the report goes on to talk about really a set of recommendations and observations that both governments and adopters and technology providers need to collaborate around in order to really to see these benefits. We were sort of privileged to be part of the research program. If anybody's interested in the study, I think you can get it certainly from our website, from the WEF, or just let me know and I can send you a copy. It's a pretty good document. So that's sort of some good news in terms of the opportunity that's being presented. However, the reality is, of course, that we're looking at an extremely complex ecosystem here. So whether it's Ericsson or Gartner, predicting 50 billion connected devices by 2020, whether that's sort of high or low, the reality is that you're still looking at some vast numbers here. So you're looking at in excess of 200 billion sensors. If you think that sort of the iPhone 6, I believe, has got either 8 or 9 individual sensors within that single device, you're talking about vast numbers of network connections across all the different networking technologies that I mentioned before and that we're all familiar with. And then sort of really on the right-hand side, what will really drive this, which will be a series of applications that will be sort of extracting and creating the business value, the analytics and the data that will be required to, or that will be there to analyze and provide the value to the industry, and underpinning it, the sort of the middleware and the APIs that will be required to transmit and allow the ecosystem to operate successfully. So it's a sort of complex environment. I think this is quite an interesting chart, actually, because it also shows really the value chain that exists in IoT and the opportunities that exist for vendors and participants in this value chain to extract value. And so if you look at, clearly you've got sort of chip designers, chip manufacturers, ARM, Intel, et cetera, sort of sitting there in the sensors side. You've got people like Apple or Fitbit or Fiat or BMW or Philips in the devices area, the telcos obviously in the network space and others, and so on. And I think it sort of shows quite interestingly the opportunities. Of course, not one of those companies is particularly sort of looking exclusively at that sort of vertical slice that they can take. Everybody is trying to play in some form across that ecosystem. So I think another good way of looking at this is that actually we're not alone in this, and looking at how we exploit this opportunity. So $1.5 billion invested by VCs last year in IoT startups and IoT companies. And you can see from the numbers here just sort of the very dramatic growth of the vendor community that's involved here. And I think that one of the real challenges is, where do you really want to play here, and where do you think there's an opportunity to make money? Because at the top end, and I know that nobody can actually see the details of these slides, but the top boxes in that chart represent effectively industry verticals, and the people that are exploiting the opportunity there are companies with deep understanding of the industries in which they're operating. And I think one of the things that we see is that there are some sort of base platform solutions that you can bring to the table here. But when you talk about actually providing value and actually extracting value, it does require significant understanding of the industry that you're working in order to really obtain that. And I think that's one of the real challenges for many of the players in the market, is they just don't have that understanding of the industry, and they really need to sort of find the right ecosystem partnerships to drive that. So that's what we believe is there in terms of the opportunity. If I look at sort of typically what it is that our clients are trying to solve for, what are the issues that sort of concern them when it comes to IoT, it sort of breaks down into three, I'd say, sort of three big areas. The first is, and this was sort of highlighted very much in the World Economic Forum report, the first is everything around how to achieve better operational efficiency. So both of their assets and of their people. How do they actually improve the efficiency of their operations? I'm going to sort of talk more about that and show you an example specifically, so I'll come back to that one later. The second, which is a really interesting opportunity, and this is this opportunity to really make the move from being a supplier of product to a supplier of services. So, for example, if you're Rolls-Royce, rather than selling an engine and selling a maintenance contract with it, what you sell is a number of hours of a successfully running engine. And you worry about the replacement of the parts, you worry about the maintenance, and your customer is basically translating what would be a capital cost into an operating cost and actually matching their operating cost with their operating expenses. So it sort of changes the dynamic quite significantly, both for the supplier in a positive way and for the purchaser also in the same way. And there's many good examples of this. We've got examples of people like in the tire industry, for example, providing sort of tires as a service to fleets. So rather than selling their tire and trying to sell that tire based on its features and its price, they've sort of translated that into providing a guarantee, effectively, of fully fit working tires that are being monitored in terms of their degradation and road usage. So some good examples there, and this is really, I think, symbolic, really, of this move towards an outcome-based economy and rather than a product economy. And of course, the advantage for the supplier here is that you're creating a much stronger relationship with your customer, a much greater amount of dependency, really, because you're providing them with an ongoing service, and sort of getting out of that service can often be less desirable and harder to do than simply trying to beat the competition based on product features. And then the last component that we're seeing an increasing interest in is what we're calling unconventional revenues. And this is really about how do you monetize the data that is being created within your environment, within your products or within your industry. So this is an area that, for example, telcos, of course, have been trying to do for several years now, sort of to monetize the data that they are creating out of the mobile phones. The problem that they've had, of course, has been historically an issue of data privacy, and how do you actually extract and do good things with that data without sort of giving the customers something for free and something that they value. I mean, this is exactly how Google and how many of the internet companies operate. They give you something wonderful that you want to use for free. In exchange, you give them your data, and actually they capitalize and monetize that data to create these revenues. And I think the IoT and industrial internet will provide, and is beginning to provide, these same opportunities because of the vast amounts of data that's being collected. And the data that might not be, that you use for one thing, might be used in a completely different way by a partner or by somebody that you could sell it to. And I think that's a sort of a real spin-out opportunity for many companies involved in this space. So if I go back to the whole area of operational efficiency, and as I said, this is really the challenge that our customers, their number one challenge that our customers want to address in terms of the industrial internet, and it's all to do with exactly this. How do they improve the operational efficiency of their business? How do they make their employees and their workers more productive? How do they make their assets more productive? How do they increase or maintain the uptime of their factories and of their plants? And how do they reduce the inefficiencies associated with unplanned breakdowns and so on? And this is where today the costs are heavy and where the opportunity is significant. And we've sort of identified really sort of two key solution areas that we think bring this opportunity to life and really create the opportunity. The first is what we're calling connected asset management. So it's basically how do you monitor, how do you connect your assets in an industrial environment, how do you monitor them, and how do you optimize the performance of them. And then the second, which is closely tied, is really how do you exploit the opportunity around connecting your workforce. So those are the sort of two key areas that we believe will impact the industrial internet and our clients in that space. If you look at the area of connected asset management, this is really applicable across the entirety of all of the industries that I talked about before. So whether your asset is a field, you're a farmer and your asset is a field, whether it's a manufacturing plant, in process manufacturing, discrete manufacturing, whether it's an oil and gas, whether it's a mine or whatever. And the biggest opportunity here is, and I'm not sure how well this comes out on the slide, I apologize for that, but the biggest opportunity here is really to take customers or to take organizations through a real journey in terms of how to make better use and to optimize their assets. And one of the biggest issues that exists right now is that actually many of the assets that exist in an industrial environment are in fact already instrumented. So there is data actually being collected from those devices. The problem is that in most cases, the instrumentation of that data is done in a very, very siloed way. So you've got a pump from one manufacturer. Well, that manufacturer can extract data from that pump, and that goes into a certain software system, into a certain database. However, that's typically not being correlated in any way with any of the other operational data that you're extracting from your devices. That's one problem. The second problem is that there are still many devices out there and many machines and pieces of equipment that are not instrumented or not instrumented in exactly the way that you'd like them to be. And the technology replacement life cycles of equipment in industry, of course, are completely different to what they are in the consumer space. So manufacturing plants are not simply going to throw out pieces of equipment in order to bring in the next generation of equipment that is better instrumented than the last one. So there's basically a challenge, I think, that the industry has, which is to figure out how do you do with what you've got today. How can you augment the devices and the instruments and the assets that you have out there by adding instrumentation to them externally? And you can clearly do that. I mean, you can add a vibration sensor to a pump that isn't instrumented, for example. And then how do you sort of take yourself through this maturity curve to start off by monitoring your assets, using the data that you've got, and then over a period of time, moving from that to a sort of preventative approach to maintenance, and then eventually to a predictive maintenance approach where you really are anticipating breakdowns and maintenance requirements and arranging for spare parts or replacement parts in a cost-efficient way in your supply chain. So that's a sort of a key journey and a key use case that we think all of our customers are really interested in. The second one is all around how do you make better use of your workers and how do you allow them to be more effective really at the point of execution of the service that they're trying to perform. So, I mean, there's been connected workers out there for years. I mean, we've been doing field force automation projects for 10 years or more. So, the gas installer that comes to your home to do something, I mean, they are connected. They have access to scheduling and to workflow on some sort of mobile device. But what we're talking about here is really going really to the next step, to allowing workers to use, for example, wearable devices that go well beyond anything that they've been using up to now, allows them, for example, to receive sort of over-the-shoulder coaching and collaboration from an expert, or allows them to view schematic diagrams through wearables with their hands free in order to do work. So combining sort of collaborative activity, health and safety, which is becoming an increasing issue, but actually, unfortunately, is probably not a significant driver of return on investment for most companies by itself. And then the third is sort of tracking in order to be able to understand in large plant environments how your workers are working, where they need to be, and how to optimize their movements around that. So it's really the combination of asset management and connected worker that we think are sort of the two key use cases that our clients are looking at. I'd like to sort of just finish really and take you through a specific case study, a project that we've been doing during the course of this year with one of our customers in North America. So the customer is one of the world's largest mining companies. We've been doing a project at one of their large open pit copper mines based in North America. This is sort of exactly the case that I sort of showed you before, which is that here is an environment where actually quite a lot is already instrumented within the organization, but they're not really consolidating and making good use of what they have. And IoT is really sort of unlocking the value for them in that sense. So I don't know if any of you have ever been to a large copper mine, open pit copper mine, but these things are very huge. They're many hundreds of square miles in reach. And they employ thousands of workers and trucks. They're operating typically here, on this particular mine, they're operating 2 12-hour shifts, 365 days a year. So this is a non-stop operation. And they do have a remarkable amount of information already in terms of, I'm not sure how well you're going to be able to see that, in terms of the devices and instruments they have. So, for example, they have radar that sort of tells them how the slope of the mine is moving. They have water measuring systems to understand how much water there is in the mine. All of their trucks are connected, and they have telematics inside the trucks. They know where the trucks are, what they're doing. They've got fatigue monitors that are there for their drivers, so they understand what's going on. They've got all sorts of data that's being collected. Interestingly enough, though, the way they use that data is that the supervisors actually receive at the beginning of each shift a pack of printed paper that represents the state of the mine at the beginning of that shift. And they receive no real-time updates to that during a 12-hour shift. So basically, they sort of have a starting picture, but then they have no way of understanding how that is changing during the course of the day and how they can make operational decisions that will allow them to be more effective in terms of what they're doing. They have two-way radio. But to give you an idea, if they get called up and say, well, there's a problem, a truck's broken down at a certain location, I mean, it can take them 30 or 40 minutes to drive from where they are to see that truck, and then, it's another 30 or 40 minutes to go back to where they were. So, I mean, you're talking about vast distances that need to be covered in order to be effective here. So, what have we done with them? We basically instrumented some more of their devices that hadn't been instrumented. We collected all the data, we consolidated it all, we put it into a cloud, and in this particular case it's Azure that we put it into, and then we created a series of applications for them, and then armed their supervising team with ruggedized tablets and phones, and gave them a mechanism really for making operational decisions during the course of the working shift, and to receive alerts and alarms both on their phones or through other wearable devices during the course of the day to react to things. I just want to show you a couple of, just to close off here, with a couple of the sort of quick things. First of all, to give you a sense here, this particular mine actually mines 500,000 tons of copper every day. Sorry, not every day, every shift. And so one of the things that they just actually had no way of seeing was in real time how much they were actually mining and how much they were sort of picking up in their, with their shovels and their lorries and mining. So one of the things that this overview gives them is actually a view as to what their forecast is for the shift, what their target is, and it allows them to start thinking about what are the changes they need to make, or where should they be looking if there are problems and issues and they seem as if they're under forecast. There's a whole bunch of other very sort of mining technical stuff here that is also being captured. And then we give them a sort of a dashboard which allows them to look at all sorts of different aspects of the mine. This is sort of quite interesting. Unfortunately, this is just a PowerPoint. It's not part of a live demo. But they actually have heat maps that allow them to understand which parts of the mines are the most productive. So which parts of physically of the mine, has got the highest ore content or medium grade and things like that. And they actually can see in real time where their shovels are actually digging. And these move, and they can see this updated on a 30-second basis. And so they can actually make decisions during the course of the day how they should direct and how should they point their shovels in order to optimize the best that they're getting out of the mine. And then this last one I want to show you is just the tracking that's done around the truck. So a truck in a mine like this has a capacity of something like 80 tons. So I don't know, what's that, 40 Range Rovers or something like that. So maximizing the use of these trucks is a sort of a fundamental metric and KPI in terms of the way the mine works. So here we're actually tracking which trucks are actually in use and are ready, which trucks are being delayed, they might be refueled, or there's some particular reason why there's a problem with the truck, which trucks are in for repair. So basically this is a real-time view of every single aspect of that trucking operation. So just want to give you an example. This is, and as I say, and this is delivered on ruggedized tablets to supervisors. They have alerts that they receive. They can set up all sorts of triggers for what sort of alerts they want to see. And all of a sudden, they're taking what's quite a static way of operating and turning that into a real-time and dynamic way of running their business. As I say, I mean, I want to just show you this because I think it really is symptomatic and sort of a characteristic of the sort of problems that we're going to see solved by the industrial Internet of Things over the next few years. Good. Thanks. I'd like to stop there.
Wrap it up there, Ben. Thank you very much.